Hello friends, today we learn the type of t-test. There are three types of t-test, one sample t-test, two sample t-test and the paired t-test. Today we learn the two sample t-test. This test is also called as independent t-test. So this use of this test is to compare the means of two separate and unrelated groups. The two classes we will compare their means and check whether they are significantly different or not. Example is given to you. There are two classes, class A and class B, and average marks of the student for a particular, these are the marks of a, suppose DSBDS subject. 3 students from class A, 3 students from class B. We check whether these marks are significantly different or not. So my hypothesis, first I formed the null hypothesis. This is no significant difference between two classes. First I assume that there is no significant difference. Now my H1 is, there is a significant difference. There is a significant difference between two classes. This is my alternate hypothesis. As you know, alternate hypothesis is opposite to the null hypothesis. Now second step, we calculate the t statistic. In chi-square test, we calculate chi-square statistics. So formula for t statistic is t equal to x1 bar minus x2 bar. x1 bar is nothing but the mean of first class. x2 bar is nothing but the mean, that is average of second class, divided by, in square root, s1 square divided by n1 plus s2 square divided by n2. Here s1 is the standard deviation for group or class A, s2 is the standard deviation for class B, n1 is the total number of samples of class A and n2 is the total number of samples of class B. Now we calculate x1 bar. So we calculate the mean, that is average of these 3 marks. So it is 70 plus 75 plus 80 divided by total marks or total sample, that is a 3. Total 3 marks are there. So its answer is 75. So x1 bar is 75. Same we calculate x2 bar. This is for class B. So it is a 65 plus 68 plus 72 divided by 3. So it is a 68.33. So we got the x1 bar and x2 bar. So our formula we require their difference. So we calculate the difference. 75 minus 68.33. So it is 6.67. This is the first term we got. Now I want to calculate the standard deviation. Standard deviation formula is this: summation of I is equal to 1 to n in bracket xi minus x1 bar square divided by n minus 1. N is the total samples. So we put the values here. For this purpose, I calculate the x1 minus x1 bar here. So xi is these values. For class A, xi, these are the values are xi. For class B, these are the values for xi. So my xi values are 70, 75, 80. Xi minus x1 bar. x1 bar already calculated. So it is a 70 minus 75. This is x1 bar and this is a xi. Again 75 minus 75 and 80 minus 75. So it is a, we got as a minus 5, 0 and plus 5. We perform their square. So it is 25, 0, 25. So I put these values here. That is a 25 plus 0 plus 25 divided by n minus 1. Total samples are 3. So 3 minus 1 is 2. So answer is 50 divided by 2. So it is a 25. Square root of 25 is 5. So I calculate the S1 as a 5. Now for class B, I want to calculate S2. We use same formula for S2. We use same formula for S2. Same way, suppose Xi is, where is Xi? Yes, these are the Xi values. That is a 65, then 68, then 72. 65, 68, 72. Then 65, Then 65 minus what? 65 minus this x2 bar, that is a 68.33. So it is a minus 3.33. 68 minus 68.33. So it is a minus 0.33. Then 72 minus 68.33. So it is a 3.67. This is xy minus x2 bar. I will perform their square. So square of minus 3.33 is 11.09. Square of minus 0.33 is 0.11. Square of 3.67 is 13.47. So I will put these values here. So it is 11.09 plus 0.11 plus 13.47 divided by n minus 1. N is the total sample. So 3 minus 1 is the 2. So its total is 24.67 divided by 2. We calculate it, it is a square root of 12.34, and again its square root is 3.51. So we got S2 here. So it is a 3.51. S2 is 3.51. Now I got S1 square also, S2 square, S1 and S2. So I will use this formula. T equal to x1 minus x2 bar is 6.67. Then my S1 is 5. I want their square. So 5 square plus S2 square, that is a 3.51 square divided by now N1. N1 is the total samples in class A, that is a 3. N2 is total samples in class B, that is a 3. So it is a 5 square is 25 divided by 3 plus 3.51 square is 12.34 divided by 3. We perform their addition. It is a 12.44. So 6.67 square root of 12.44 is 3.53. We perform this calculation and final answer is 1.89. This is my T statistic, that is a calculated value of T. Now I want to find out the critical value. How I find out the critical value? Using the degree of freedom and the significance level. We always assume the significance level is 5%. Our alpha is 5%. So first we check this example comes under which type of test, whether it is a one tail test or two tail test. As we use a symbol in the H1 is a not equal to. Here H1, H0 we write as a no significant difference between two classes, and H1 is there is a significant difference between two classes. Here we not use the word not equal to, because already in H0 we define that is there is a no difference. Means this is opposite to this sentence. That's why this is a two tail test. Here I am not using the not equal to word or not as a sentence, but it is a reverse of the H0. That's why it is a two tail test. Means we consider the value of alpha as a 2.5%. Means I have a two table. One table is for one tail test, another table is a two tail test. So I will refer the table of two tail test having value 5% or one tail table test having the value 2.5%. So this value is 2.776. So how I calculated this value? First I calculated the degree of freedom. Degree of freedom is formula for this test is N1 plus N2 minus 2. N1 is the total samples in class A. N2 is the total samples in class B. So it is a 3 plus 3, that is a 6. 6 minus 2 is a 4. So degree of freedom is 4. So my calculated value, for calculated value I write 3 T 2.5 comma it is a 2. So this is a value of significance, that is a 2.5% here I consider, because I use the two tail test here. So its value is 2.776. Its value is 2.776. This is my critical value, and this value 1.89 is my calculated value. Now I will compare this calculated value with the critical value. So critical value is suppose 1.89. Critical value is 1.89, and I will check this value with 2.776. As you know, 1.89 is less than 2.776. So we here accept the H0. We accept the H0. here we accept the H0. That means there is no significant difference between two classes. Their average is approximately same, not as a more difference between their mean, that is the averages. So this is all about the two sample test. Here we use the two tail test because our H0 is exactly opposite to the H1. Thank you.